Hi guys, welcome back to another session on second order differential equations. So today we are actually going to get into solving real second order differential equations. And we're going to be looking at an example where we have a situation where the roots are real and distinctly different. So as you can recall from last session, differential equations, the second order is given as follows in the form A d2y dx squared plus b dy dx plus cy equals 0. For it being equal to 0, that means it's a homogeneous differential equation. Now, the first thing you need to consider when you're solving second order differential equations is to have an auxiliary equation. And your equations are always given in the form A, m squared plus bm plus c, where a, b, and c are those coefficients in your equation. So let's see how to apply this to an actual question. So suppose we were given 3 d2y dx squared plus, let's change the sign, minus 4 dy dx plus y being equal to 0. Now, the first thing you need to decide when doing differential equations are to first figure out what's the order. And we can see we have a second order here, and it's homogeneous. That means our solutions will take a nature of finding an auxiliary equation. Now, first thing I want to do on the side is to simply state my values of A, B, and C. Now, my values of A are 3. My value for B is -4. And my value for C is simply that coefficient of y, which is +1. Having those values, I am now able to write out my auxiliary equation. My auxiliary equation will simply be 3m squared minus 4m plus 1 equals 0. Now, we can go ahead and we can use the quadratic to solve this auxiliary equation, but we can factorize and we can also solve this by sight. I can tell that this is 3m minus 1 and this will be m minus 1. This implies that we have two distinct real roots where one root m1 is given by a third, and our second root, we'll call that m2, is given by 1. Because we have found, using factorization, we have found out that our roots fall under the case where they are real and they are distinct. Then our general solution for this will take a special format. And for this type of equation where we have real distinct roots, our general solution is of the form y is equal to a e to the m1x plus b e to the m2x. Substituting my values of m1 and m2 into this general solution, I will simply get m1 has a value of 1/3 and m has a value of 1. We can leave that as just x. So this is our solution for this type of second order differential equation. Now, we'll go ahead and we'll look at an example where our roots may not exactly be real and distinct. I think I might clear my screen here. Okay. So let's just say, for example, we were asked to solve the following differential equation. And we were given 4 d2y dx squared minus 4 dy dx plus y being equal to 0. Now, upon first sight, you can tell that it is definitely a second order differential equation. And our right-hand side is equal to 0, so it's a homogeneous differential equation as well. So that will take special general solutions. Now, equation of this type once more has an auxiliary equation. And in order to use that auxiliary equation, we will first state our values of A, B, and C. A has a value of 4, B has a value of -4, and C has a value of 1. Therefore, for this question, our auxiliary equation will be given by 4m squared minus 4m plus 1 equals 0. Once again, you can apply the quadratic formula, but we can actually factorize this very simply, and you would get 2m minus 1 by 2m minus 1. Straight away, you can identify that your roots seem to be repeated, where you have m being equal to positive 1/2. Because this is a case where your roots are repeated and real, we do have a special general solution for this type of question. And our general solution when roots are repeated are of the form y is equal to e to the mx by ax plus b. For this question, we have found the value of m to be 1/2. So we will simply replace that m with our repeated root, which is 1/2. And that's our general solution for when we have a case where we have real or repeated roots. Now, let's go on to look at an example where we have neither repeated roots nor distinct roots. So this is our third example here. Let's just say we were asked to solve the following differential equation. d2y dx squared plus 2 dy dx plus 4y is equal to 0. Now, the first thing you need to make sure is to identify if it's a second order differential equation. We can see that the highest derivative is to the power of 2, so it is a second order differential equation. Check. Also, is it homogeneous? Well, we can see on our right-hand side, it's being equal to 0, so it's definitely homogeneous. Check. So we can apply the auxiliary equation type solution. Now, before we can find our auxiliary equation, we need to identify our values of A, B, and C. A is the coefficient of that first term, which is 1. B is positive 2, and C has a value of 4. Therefore, we can write that our auxiliary equation is simply given by m squared plus 2m plus 4 equals 0. Now, for this type, you can tell that you cannot factorize this simply. You have to apply the quadratic formula. In applying the quadratic formula, we will get m is equal to -2 plus or minus the square root of 2 squared plus 4 by 1 by 4 all over 2. This simplifies to -1 plus or minus the square root of 3i. Now, when you have found a case where your roots are imaginary, then your general solution takes a particular form. And it goes like this: y is equal to e to the px, all open brackets a cos qx plus b sine qx, close bracket. Now, where do the values of p and q come from? Well, based on your solution of your imaginary root, the value p is actually your real part of your root and q is your imaginary part. Substituting those values in, you will get p was -1x or negative, and q, we can erase our q's and replace it by √3. And there you have it. That's your solution to this second order differential equation. So starting from the top, you have second order differential equations where your highest derivative is of the power 2. And these are all linear second order differential equations. And they are homogeneous, meaning that that right-hand side is being equal to 0. They all possess some form of auxiliary equation in the form am squared plus bm plus c equals 0. You can factorize simply, or you can use the quadratic formula. There are 3 different types of situations that you may encounter, and each different type of situation takes a different general solution. Take your time, review this video. You can start back from the beginning. You can take it slow, but I hope that at the end, you are able to successfully understand the 3 different types of homogeneous second order linear differential equations. And at the end, take a deep breath and say, yes, I did it. Because it seems very, very, very taxing remembering all those different types of general solutions. It is a lot. I personally admit it is a lot. Sometimes I do forget and I have to take a little sneak into a textbook, you know, just to refresh my memory, because you can get so mixed up with so many different formulas. And as a student, I know that you guys do not have that privilege of taking a sneak peek into a textbook during the exam. So sometimes it can definitely feel very, very overwhelming. But do you know some tips and tricks that can help you from feeling so totally overwhelmed? Once you practice, and you practice a lot, your brain gets a chance to process what is taking place, and it works on memory. And what happens is that it starts to remember what you have practiced over time as becoming routine. And once a routine happens, you don't essentially have to spend so much energy trying to forcefully recall 2,900 different types of formulas and general solutions. Okay, guys, so practice is what's going to get you to a point where your revision is going to be very, very nice and simple. And if I wanted to set a time limit with you guys to how long essentially you should spend practicing a particular subject, I'd say no longer than 2 hours and no less than half an hour. Within this time frame, studies have determined that actually the human capacity of the brain peaks within this time frame. It takes roughly about a half an hour before your brain is able to process the information that's new and fresh. And during that time, after processing, it's able to apply whatever formulas it has learned and apply to questions. But after that 2 hour period, it starts to get tired and it needs to rest, it needs to rejuvenate itself. So I know a lot of students spend hours upon hours revising night before exams. Sometimes it may not be the best idea. That may also explain, guys, why sometimes you tend to blank out before an exam. So I hope these tips have helped you guys to change your studying habits for the future, especially my kids who are listening right now. You know who you are, because you have been asking me what to do with the 2 months you have left before you write your exam. So I'm gonna definitely do that video that you guys have been requesting to see sooner than later. Okay, guys. So all the best. Glad to be with you, and I look forward to seeing you guys next video. Take care and goodbye.